Hey everybody, this is Mr. McKee again with SEC 210. Today we'll be going over Lab 4.2.6, which is working with text files in the CLI, or Command Line Interface. Notice I have up my CyberOps workstation VM. I actually changed the background image because it was like too busy. But if you right click and click if you right click and click Desktop Settings, you can change the background. Like that was the original background. And actually, you know what? I kind of like that one the best. I don't know, maybe that one. But anyways, I just changed that to make it a little bit easier to see. Yeah, I think that'll work. Alright, but anyways, let's go ahead and get started. Okay, today we'll be working with graphical text editors, command line text editors, and working with configuration files. Alright, before you can work with text files in Linux, you must be familiar with text editors. Text editors are one of the oldest categories of applications created for computers. Linux, like many other operating systems, has many different text editors with various features and functions. Some text editors include graphical interfaces, while others are only usable via the command line. Each text editor includes a feature set designed to support a specific work scenario. Some text editors focus on the programmer and include features such as syntax highlighting, bracket matching, find and replace, multi-line regex or support, spell check, and other programming focused features. To save space and keep the virtual machine lean, Cisco CyberOps Workstation VM only includes Cite as a graphical text editor application. Cite is a simple, small, and fast text editor. It does not have many advanced features, but it fully supports the work done in this course. Alright, and it says, note, the choice of text editor is a personal one. There's no such thing as a best text editor. The best text editor is the one that you feel most comfortable with and works best for you. Alright. And actually, I think it's pronounced Skype. Open Skype from the GUI. Log onto a CyberOps VM as the user analyst using the password CyberOps. The account analyst is used as example. User account throughout the lab. I'm sorry. All right. Let's see. Now if I go to CyberOps and Skype. All right. So it looks kind of like a notepad. All right. So Skype is simple but includes a few important features: tabbed environment, syntax highlighting, and more. Spend a few minutes with Skype in the main work area. Type or copy and paste the text below. Now I don't have drag and drop working on this. Actually, I wonder if it'll let me install that. I don't think it'll let me do that. But anyways, you would have to type it in. Alright, unless you run, now if you open up this file, unfortunately this file is in Word, you'd have to have Word installed, or it's not going to let you copy and paste it, I don't believe. But what you want to do is space is a big, really big place, ... Okay, that's all I'm gonna put in there. All right, click File, Save. All right, it asks me where I want to save the file. Notice I'm in the home directory for Analyst. Name the file space.txt and click Save at the bottom right. Close Skype by clicking the X in the upper right corner of the window and then reopen. Alright. Click File, Open. And search for the newly saved file space.txt, and notice I don't see it. Alright, can you immediately find space.txt? Nope, I don't see it right now. Okay, even though Skype is looking in the correct directory home analyst, space.txt is not displayed. This is because Skype is looking for known extensions and txt is not one of them. To display all files, click the drop-down menu at the bottom of the Open File window. Right there, all files. Okay, select space.txt, which is the very bottom, and open it. Note, while the Linux file system do not rely on extensions, some applications such as Skype may attempt to use them to identify file types. Close space.txt when finished. Alright, so now we're going to open Skype from the terminal. Alternatively, you can also open Skype from the command line. Click the terminal icon located at the dock at the bottom of the desktop. I know you can go up here, but we're just going to follow it the way it's telling us to do it. Alright, type SCITE, which is the application, space.txt, which is the file. So note that this will not only launch Skype but in the GUI, but also automatically load the space.txt file that was previously created. Alright, so notice that. That's pretty cool. Alright, notice that while Skype is open on the foreground, the terminal window used to launch it is still open in the background. Alright, so it's actually still running Skype from the command line. Alright. Why is the prompt not shown in the terminal? It's because it's using up this terminal to run that application. Alright, so if you want to stop that process running, if I click back in the terminal, what did it say? Control C. Alright, notice how that stops that process. Alright, and that is it for that. Alright, part 2, command line text editors. While graphic text editors are convenient and easy to use, command line text editors are very important in Linux computers. The main benefit of command line based text editors is that they allow for text to file editing from a remote shell on a remote computer. Consider the following scenario. A user must perform administrative tasks on a Linux computer but is not sitting in front of that computer. Using SSH, the user starts a remote shell to the aforementioned computer. Under the text-based remote shell, the graphical interface may not be available, which makes it impossible to rely on graphical text editors. In this type of situation, text-based editors are crucial. This is mainly true when connecting to remote headless servers that lack a GUI interface. Alright. So the CBROPS, Cisco CBROPS Workstation VM includes a few command line text editors. The course focuses on Nano. I like using Nano myself. Right, another extremely popular text editor is Vi, or they have Vim. While the learning curve for Vi is or V is considered steep, V is a very powerful command line text editor. It is included by default in almost all Linux distributions, and its original code was first created in 1976. The updated version of Vi is Vim, which stands for Vi Improved. Today, most our V users are actually using the updated version of Vim. Due to the lack of graphical support, Nano can be controlled solely through the keyboard. Control O saves the current file. Control W opens the search menu. The Nano uses a 2-line shortcut bar at the bottom of the screen, where a number of commands for the current context are listed. After Nano is open, press Control G for the help screen and a complete list. Alright, in the terminal window, type Nano space And notice how I'm tabbing over, as long as that's a unique name, they'll let me tab over. And notice it opened it up. That's just a no frills text editor. Right. While the text may seem to be truncated or incomplete, it is not. Because the text was created with no return characters and lines wrapping, it is not enabled by default. Nano displays one long line of text. Now notice I only typed in about, what, 7 words, so that's not an issue anyways. Use the home and end keyboard keys to quickly navigate to the beginning and end of a line, respectively. So if I hit home, it goes to the beginning, end goes to the end. Alright. What character does Nano use to represent a line that a line continues beyond the boundary of the screen? Now if I went to the, see if I did end and I did all dots. Alright, and then I go back, hit home. Alright, so if I hit end again, hit home, notice that it adds something on there. Now let me try to do this too. I'm going to do all S's, S, 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 home. Alright, maybe you can see it better there. Okay, one thing to remember, now you see I'm using a the greater than sign, or it's showing greater than sign. Sometimes you'll see a dollar sign, depending on the older version of Nano is going to show you a dollar sign. So everybody should have the greater than sign. Alright, as shown on the bottom, shortcut lines, control down here, it's talking about down here at the bottom. Control whatever that is. It has like a caret X, so that means control X to exit, control certain things to do there to save it. Alright, Nano will ask you if you want to save it before exiting. So if you do control X, it automatically says save modified buffer. Alright, if you hit Y, you'll be prompted to press enter to accept the given file name or change the file name or provide a file name that is new unnamed for the new unnamed document. Alright, so if I hit Y, file name to write, and then you'd hit enter, space.txt. Now I could change that. I can go back there and change that, but I don't want to. Alright, so I'm just going to hit enter. Now if I go do the up arrow, I can go back into that same file. So to control Nano, you can use Control, Alt, Escape, or the Meta keys. The Meta key is the key on the keyboard with the Windows or Mac logo. Alright, I'm using a Windows machine, so I have a Mac. I'm using a Windows machine, so I have a Windows key. Depending on your keyboard configuration, navigation in Nano is very user-friendly. Use the arrows to move around the files. Page up and page down can also be used to skip forward or backwards entire pages. Spend some time with Nano and its help screen. To enter the help screen, press Control G and press Q to quit the help screen and return to the document editing in Nano. So if you do Control G, alright, there's the help screen. Right? It tells you a whole bunch of stuff you can do. I use Nano a whole bunch, so it works really good. And I hit Q, it takes me out of there. Alright. Working with configuration files. In Linux, everything is treated as a file, including the memory, the disks, the monitor output, the files, and the directories. From the operating system standpoint, everything is a file. It should be no surprise that the system itself is configured through files. Notice configuration files, they are usually text files and are used by various applications and services to store adjustments and settings for that specific application or service. Practically everything in Linux relies on configuration files to work. Some services have not one but several configuration files. Alright, users with proper permission levels use text editors to change the contents of such configuration files. After the changes are made, the file is saved and can be used by the related service or application. Users are able to specify exactly how they want any given application or service to behave. When launched, services and applications check the contents of specific configuration files and adjust their behavior accordingly. All right, a lot of reading here. All right, step 1, locate configuration files. The program author defines the location of configuration for a given program, service, or application. Because of that, the documentation should be consulted when assessing the location of the configuration file. Conventionally, however, in Linux, configuration files are used to configure user applications are often placed in the user's home directory, while configuration files used to control system-wide services are placed in the etc directory or etc directory. Users always have permission to write to their own home directories and are able to configure the behavior of applications they use. So let's do Control X. All right, Q out of that. All right, Control X. All right. So if you did make any changes, Control X will just take you right out of there. All right. So now if I do, I'm going to do pwd just to show you what directory I'm currently in. All right. So I'm in the home ALS directory. All right. Now use the ls command to list all the files in the home directory. All right. And ls and -l is like a long form. So that shows you these are directories. And you notice the D on the beginning of it is directory. That's a file right here. And you have read, write, and execute permissions. For the owner, they should have all the read, write permissions. The group is the next section, and they'll have read, write, or execute permissions depending on what they're supposed to have. Actually, it's right here. That's the owner or the creator. There's the group the owner is part of, and this is other users. So you'll have W, X, or R, write, execute, or read. All right, so I have for space.txt, I have read and write. Other people in my group have read, and other users have read. All right, so that's how that works. All right, while a few files are displayed, none of them seem to be configuration files because convention to hide home directory hosted configuration files is preceded by their names with a dot. All right, so if you do ls and do L for long form and A, that shows you all the hidden files also. Everything with a dot. And those are configuration files. All right. So now we're going to use the cat command, cat, and .bashrc. This file is used to configure user-specific terminal behavior and customization. All right. So you don't worry much about the syntax of this file. The important thing to notice is that bashrc contains configuration for the terminal. For example, first line defines the prompt structure of the prompt displayed by the terminal, right, which is right there, followed by a $, all in green. A few other configurations include shortcuts to commands such as ls and v. In this case, every time the user types ls, the shell automatically converts it to ls color to display color-coded output for ls. All right, the specific syntax is out of scope of this course. What is important understanding is that user configurations are conventionally stored as hidden files in the user's home directory. Alright, while configuration files related to user applications are conventionally placed under the user's home directory, configuration files related to system-wide services are placed in the etc. directory or etc directory. Alright, so we're going to use the ls etc like that. Alright, that shows you all the configuration files that are system-wide. Alright. So use the cat command to display the contents of the bash.rc file. So cat etc bash.bashrc. Alright, notice there's a whole bunch of stuff there. Well, not a whole bunch, but all this stuff here. And notice it looks like the formatting, the output on command prompt. Alright, the syntax of bashrc is out of scope of this course. The file defines the default behavior of the shell for all users. The user wants to customize their own shell behavior. The default behavior can be overridden by editing the bashrc. Right? Because this is a system-wide configuration, the configuration file is placed in the etc., making it editable only by the root user. Therefore, the user will have to log in as root to modify the bash.bashrc. Why are user application configuration files still saved in the user's home directory and not in the etc with all other system-wide configuration files? I'll let you guys just think about that. It should be apparent. Alright. But moving on. But make sure you answer those questions and put them in like light blue text, something that's easy for me to find. Alright. Editing and saving configuration files. Alright, configuration files can be edited with text editors. I'm going to do a clear. Alright. Clear command on the terminal just clears everything out. Alright. I'm going to close that down. Alright, go to Applications. Opens. State. Alright. So file open. And bashrc is hidden with no extension. It does not display it. Change the file type shown by selecting all files. Right there. Alright, select bashrc. Right there. And I had to scroll up a little bit to find it. Alright, so there it is. Alright, locate 32 and replace it with 31. Right there in the second line. Well, actually the third line, but the second populated line. Make that 31. Alright. Then do file save. And close. And then click the terminal. Open terminal back up. Alright, notice this is turned to red. Alright, did the terminal window, which was already open, also change? Oh, you know what? It wouldn't have, but I didn't have it open. So if I go back, let me do this. So if I was to go here, well, it'll tell you about, because I'll leave this here where it is. I'm going to go to Skype again. I'm going to open I'm going to go down here to all files. I'm going to go to bash rc. All right, I'm going to change this back to 2. And then file, save. All right, now I'm going to open up the another terminal. All right, notice how it didn't refresh automatically. All right, but notice I changed that back to the original color. All right, so did the terminal window, which was already open, also change color from red to green. All right, explain that. Then the same change should have been made from the command line with the text editor, such as Nano. In the new terminal window, type Nano. All right, so open our command line, which I'm going to close one of these. Well, I'll leave it open. Let's leave that open. This is our one that was changed. Right, so we did Nano, bash rc. All right, we can change it there too. And so I'm going to use my arrow keys, change it to 33, which is what 33, which is yellow. Control X. Do you want to save it? Yes. Enter. All right. If you type in bash, it reloads the bash terminal, and notice it's yellow now. All right. All right, editing configuration file for services. System-wide configuration files are not very different from user application files. Nginx, so Nginx is pronounced Nginx, is a lightweight web server that is installed on the Cisco CBROPS workstation VM. Nginx can be customized by changing its config file, which is located in etc. Nginx. First, open Nginx configuration file in Nano. So, we got to open it. All right. So what we're doing is right here is we're opening it as root or super user. We're opening the application Nano. We're enabling line numbering, and we're opening the config file in this directory. And unfortunately, I can't just go copy, paste. Yeah, it won't let me do that. So I have to type in sudo nano l tc nginx custom server. All right, what is it? CBROPS. All right, so now I'm in the config file for the web server. Use the arrow keys to navigate through the file. All right, so arrow keys go down. Just it keeps going. All right. Conventionally, .config extensions are used to identify configuration files. All right. While the configuration file has many parameters, we will configure only 2. The port Nginx listens for incoming connections, and the directory will serve web pages from, including the index.html homepage. Notice at the bottom of the window, above the Nano commands, the line number is highlighted and listed. Okay, right there. All right, on line 39, if you guys are taking CTI 110, you probably did the same thing for your web server, for your XAMPP web server. All right, so go to line 39. Right, it's listing on port 81 right now, which is probably what you guys, matter of fact, that's probably what you guys set your web servers to in CTI 110. This will tell Nginx to listen to HTTP requests on port TCP 8080. All right, next move to line 47. All right, and change the path from user share Nginx HTML to user share Nginx HTML text. All right, so HTML text underscore ed underscore lab backslash. Be careful not to remove the semicolon at the end of the line, or Nginx will throw an error on startup. Do Control X and hit yes, enter, and use the custom. Yep. So I use that automatically. I didn't even look at it when I did it, but I did it. All right. Type the command below to execute Nginx using the modified configuration file sudo nginx. All right. C custom server.conf. All right. So notice it came back to the command line, so now it should be running. All right, on the address bar, open up a web browser, and we're just going to go to localhost, which is 127.0.0.1 colon 8080. Whoops, 8080. All right, notice as part of the working with text files lab, you've successfully configured Nginx. All right. All right. After successfully opening the Nginx homepage, look at the connection message in the terminal window. All right. What is the error message referring to? And you guys can look. You can look at that, but you can actually search this get flavicon.ico http. You guys can look up that error. All right, I'll leave that to you guys to do. All right, to shut down the Nginx server, press enter. All right, so sudo pkill, which says process kill Nginx. All right, so now that just stopped the web server. We can test whether the Nginx server is indeed shut down by first clearing the recent history in the web browser, and then close and reopen the web browser. All right, so I'm gonna try to just shut it down and then open it back up. I don't think it cached that page. I guess it did. Let's go up here. Let's go to is it edit maybe? View history, clear recent history, clear now. All right, now let's go to 127.0.0.1 colon 8080. All right, notice now you can't get to it. Does the web page appear? You should be able to answer that. All right, challenge question: can you edit the custom config file with site? Describes the process below. Remember, because the file is stored under /etc, you will need root permissions to edit it. All right. So reflection: depending on the service, more options may be available for configuration. Configuration file location, syntax, and available parameters will vary from service to service. Always consult the documentation for information. Permissions are a very common cause of problems. Make sure you have the correct permissions before trying to edit config files. And more often than not, services must be restarted before the changes take effect. All right, so you guys can play around with definitely the command line, the terminal, the bash shell, and Linux. Takes a while to get used to, but once you get in there, and you can do a lot of stuff in there. All right, so submit your 8 questions, your answers to your 8 questions, and that is about it. Pretty soon, though, for the labs, I want to make you guys submit screenshots, but just for now, all you have to do is answer the questions. Right, and that's it. Thanks for watching.